In this video, you're gonna see why I'm making a really strong case for teaching a child the big 7 long division method first before teaching him the more traditional algorithmic long division method. Okay, here's how the big 7 long division looks like. 512 divided by 3. Now this all looks familiar until I draw this long line here. Then parents go like, what's going on? Don't worry. Essentially what this question means is how many 3's can we pull out of 512? So let me just pull out 100 3's first. That will make 300. And then when we subtract, we get this. Can we still pull out 100 3's? No, we cannot. The next number I would teach children to use is 50 because by the time they're 9 years old, they have mostly memorized their 10, 5, 2 multiplication tables. So we used numbers that are in multiples of 10, 5, and 2's. Right, so this makes 150. Subtract this, you get 62. And now you can't use 50 anymore because that makes a number too big, so you're going to go down to 20. And there you have it. You can't take out any more groups of 3 from this, so you stop. So altogether you have pulled out 170 groups of 3's with the remaining 2 still left on the table. Now compare this to the traditional way of long division. How many 3's can we pull out of 5? 1 3. Then we multiply to get it here. We subtract. We get a remainder. Now we bring down the next number. We bring it to 1. And so you need to know what your multiples of 3's are. If you get this part wrong, if you put an 8 here thinking it's 21, everything's messed up, right? So hot bit of careless mistakes. So 3 and 7 we know is 21. And then you get a 0. But you still have to bring down this 2. Now most students will stop here and say, I found a remainder, because most students don't get why you have to multiply by 0 to get 0. Why are we making a 0 for? It doesn't make sense. You've never had to do that in other calculations and computation. Why now? So you got to explain that logic as well. And you can see now it's finally a remainder of 2. Yeah. So the careless mistakes would happen over here because they have not mastered their multiplication table at primary 3 or 9 years old, which is, to use this method is necessary too. And then they don't get why they have to make a 0. They don't get it. Okay? And also another case for the big 7 method is that you can also use really small numbers to start teaching the logic of it. You can still use this. So how many 4's can we take out from 9? Let's try 2 4's. We make 8. And so we can take 2 4's out with a remainder of 1. The number can get to a point where even if they do not know their multiplication table, if they just try one group at a time, they will still eventually get the answer. So it's 2 groups with a remainder of 1. So the mastery of multiplication table is not necessary for long division. And so it takes we get to get them to focus on that one skill, but along the way, along the years, they will improve in their multiplication facts, and then the algorithm would make more sense for them, would be much faster for them. But bear in mind that this algorithm, you won't use it. You'll rarely ever use it once you get into your teenage years. It's only in the preteen years that they will use this algorithm. So again, this is algorithm. But this is logic. That's why I recommend this. Yeah.